Hello everyone, in this video we'll be discussing the acidic character or the acidity of alkynes. Now we know this is alkynes, means carbon to carbon triple bond. This is an alkyne molecule. Now in alkyne the carbon is sp hybridized in alkynes, while in alkenes the carbon atom for both the carbon it is sp2 hybridized, and in alkanes the carbon atom is sp3 hybridized. Now if we see the hybridization in all the three hydrocarbons, we see that our alkynes, the carbon atom in alkynes is sp2 hybridized, sp hybridized, or this is for this is alkynes, this is alkenes, and then this is our alkenes. Now the hybridization is in this way. Now we know that in the S character for sp3 hybridization, here our S character would amount to only 25%, and P character is 75% here. Now in the case of alkenes, our S character is 33%, and then our P character is 66%. Now in alkenes we have S character is amounting to 50%, and even our P character for 50% is. Therefore we see that if we compare all these three hydrocarbons, we see that the S character of alkynes is more as compared to alkenes and alkanes. Therefore now S character, when S character is more, as the electronegativity, we know that electronegativity depends on the S character. Now if S character increases, if our S character increases, electronegativity will also increase, thereby it will increase in the lead to the result in them increase in acidity. Therefore this is known to us. If S character is more, electronegativity will increase, and thereby increasing the acidity of the molecule. Now it is from here we see here that if we compare the three hydrocarbons, alkynes have more S character. Therefore our alkynes will show an acidic character, in this case. Now the s orbital, we know that the s orbital, they are nearer to the nucleus. Therefore the electron pair of bond on this, the electron pair of bond will be more attracted towards the nucleus, and so the orbitals having more S character are attracted more towards the nucleus, showing higher electronegativity. And that's the case in which when S character increases, the electronegativity will increase, thereby resulting in an increase in the acidity of the molecule. Now another thing is also, now when sodium metal and soda amide Na and H2, these are strong bases. They are strong bases. Now they react with ethyne to form sodium acetylide with the liberation of dihydrogen gas. Now when these are ethyne, when it reacts with sodium, we will be getting with the liberation of hydrogen gas. Therefore hydrogen gas is liberated in this way. Therefore from here we can see here that now this is, if it further reacts now with another sodium, and with another sodium will be having carbon to carbon triple bond, negative, Na plus, and then the removal of half of H2. Now this is the way in when sodium reacts with ethyne molecule will be getting, this is known as monosodium ethynite. This is known as monosodium ethynite, and this is disodium sodium ethanite. Now what happens when it reacts with soda amide? CH, let's take H. When it reacts with soda Na and H2, we will be getting CH3C plus, and there will be removal of an H3. This is known as sodium PrOPY propionate. There will be formation of this sodium acetylite or sodium propionate or disodium ethyl. This is ethanite. Therefore, these reactions, the reactions of ethane with sodium and NH2 is shown only by this ethane molecule, and our alkenes they do not show these reactions are not observed in ethene and alkenes. Therefore, this also indicates that our ethane is acidic in nature in comparison to our alkenes and our ethane. Therefore, this is the way in which these reactions are. We see here that the reactions are not shown by alkenes and alkanes. Hence, it is also used for this direction of sodium and soda amide is also used for distinguishing between the three hydrocarbons, that is between alkanes, alkenes, and alkynes. Now let me explain it again. We see that our alkynes have more S character here. Therefore, since it is sp hybridized, due to the maximum percentage of this S character, that is 50%, the sp hybridized orbitals of the carbon atoms in the ethane molecules, they have high electronegativity, and hence these molecules will attract the shared pair of electrons, carbon to hydrogen, that is the shared electron pair of the carbon to hydrogen bond of ethane to a greater extent than that of this sp2 hybridized carbon atom and sp3 hybridized carbon atom in ethane. Thus, we can see that in ethane, the hydrogen atoms, since the bond become polarized, the hydrogen atoms attached to these triply bonded carbon atoms, they are acidic in need. They can be easily liberated, and that shows that the hydrogen atoms are acidic in nature. And therefore, in this way, the acidity of alkynes is explained.